Right. Next up is to look at some of the rules under differentiation, some of the basic rules under differentiation. Okay. So the first rule we're going to talk about is what we call the constant rule. Okay. The constant rule, or what is called the constant function rule. The general idea for differentiation is that you multiply by the power, you reduce the power by 1. That's the general rule for differentiation. Multiply by the power, reduce the power by 1. What are you multiplying by the power? Multiply the coefficient of that function you are given, or the coefficient of the function you have, by the power of that same function. Then you reduce the power of the function by 1. So multiply by the power, reduce the power by 1. But if you are given a constant, okay, a constant could be, say, you have y is equal to 5. The differential of 5, or the derivative of this 5 over here, is equal to 0. That's the constant rule. It says that anytime you differentiate a constant, it is 0. It goes away. Okay. So the derivative of, let's say, y is equal to 15, dy over dx will be 0. It goes away. If it's f of x is equal to 15, then we'll say f prime of x is equal to 0, right? So if you are given f into brackets, or say, we'll say f, right, into brackets x is equal to 15, then we would say that our f prime, right, f prime of x is equal to what? 0, right? Simply telling us that the differential of the function, say 15, which is a constant. Constant simply means that it is a number, or it is just a whole number without any variable attached to it. We don't have x here, right? So it is a constant. Anytime you differentiate a constant, it goes away. It turns out 0, so you don't write anything. You just leave it like that. It goes away, right? The second rule is what is called the power function rule, or the power rule. The derivative of a power function y is equal to f of x, which is equal to x to the power n. So we've been saying earlier on that y is equal to f of x, or f of x is equal to y, because the function can be given to you like this: y is equal to a function, or f of x is equal to the function. But when that function is being raised to a power, how do you differentiate it? So it says that dy over dx, right? So if it's given in terms of y, say you have y is equal to a function, you will say dy over dx. But if it is f of x is equal to a certain function, we will say f prime of x. Then we differentiate. So if you have x to the power n, how do you differentiate it? It is having a power of n here, right? So we say to differentiate x to the power n, it is multiplying the power by the coefficient. So the coefficient of this x to the power n is 1. Then n times the 1 will give us n. So it is n x raised to the power n minus 1. So it's simply multiply by the power, that will give you the n, then reduce the power by 1. That is what? N x raised to the power what? N minus 1. Multiply by the power, as the coefficient of 1, by the power n, that will give us the n over here. Then x raised to the power, the same power, minus 1. Okay, that's how we differentiate a power rule or a power function, right? Okay. So an example is that find the derivative of y is equal to x to the power 4, right? This function here is raised to the power. It's a power rule that we're going to use, okay? So say dy over dx, right, is equal to, multiply this coefficient of 1 over here by the power, that will give you 4. Then we'll say x raised to the power, the same power of 4 minus 1. Multiply by the power, reduce the power by 1, right? So that will give us 4x to the power 4 minus 1. That's equal to 4x to the third, or 4x cubed. Okay. The second example is to find the differential or the derivative of the function y, which is equal to 1 over x to the fourth, right? we have been asked to differentiate this, or we have this function to differentiate. The whole idea is that to make it easier, okay, to make this function easier to differentiate, we will just rewrite this function. So it says that note that y is equal to 1 over x to the fourth is equal to x to the power minus 4, right? Indices, isn't it? This has a power of 4, which is a positive value. If you rewrite this function, x to the power 4 comes up here, then the power becomes a negative value. So it is x to the power of negative 4. Therefore, we can what? We can differentiate this function now, right? It becomes easier because it's raised to a power, and then we can use the power rule. So we'll say that dy over dx, because the function, we have y here, isn't it? So dy over dx, the differential of y with respect to x, so dy over dx is equal to negative what? 4x minus 4 raised to the power negative 4 minus 1 multiplied by the power, reduce the power by 1. The coefficient of 1 here multiplied by the power negative 4 gives us negative 4. Then x raised to the power negative 4 minus 1. That gives us what? Negative 4x to the power negative 5. You can leave your answer like this, fair enough, or you can go ahead and just rewrite it just to see how the question was given, right? So we'll say this function here, or this term here, is the same as negative 4 over x to the fifth, right? This x has a power of negative 5. So indices, if it comes down like this, the power will be a positive value, right? So this is the final answer. Right. Okay, so let's continue. Note that since the derivative is a function of x, right, the derivative values of x may result in different values for the derivative. So if you differentiate a function and at the value of x you have say 2 or you have 3, then that means there will be different values for the derivative, right? So an example, practical example is here. Say the differential of x to the power 4, right? The differential of x to the power 4 is equal to 4x to the third, right? So if you differentiate x to the power 4, multiply 4, or the coefficient of 1 by 4, that will give us 4. Then x to the power 4 minus 1 will give us 3. That will give us 4x to the third. So having this, and then the value of x has been given at 1, right? Then that means f prime of x is 1, right? So in place of x, we just put 1 there. That will give us 4 times 1 to the third, right? 4 times 1 to the third, and 1 to the third is 1. So 4 times 1 will give us 1, right? Then at the value of x being equal to 2, then that means the derivative of that function at x being equal to 2 will replace 2 in place of x. So in place of x, we're going to put this 2 over there, and that will give us what? 4 into brackets 2, right? All raised to the what? The power 3. 4 into brackets 2 all raised to the power 3, right? And then we know that 2 to the power 3 will give us what? 8. So simply 4 times 8, that will give us 32. So we note that the derivative of the function that we have here at different values of x, it resulted in what? Different values for the derivative. At the point where x is equal to 1, we had the derivative to be what? 4. At the point where x was giving us 2, the derivative of that function was what? A value of 32. Okay. The third rule under differentiation is what we call the generalized power function rule. Generalized power function rule. It's just a build-up of the power rule or the power function rule. But now you have a number which is greater than, let's say, 1 being your coefficient. Remember that when we did the power function rule, here we were having say x to the fourth, y is equal to x to the fourth, which is having a coefficient of 1. Under the generalized power rule, you could have the same x to the fourth or x to the third, but the coefficient is more than 1. So here you can say the coefficient of x cubed is what? 5, right? So for a function, say f is equal to the coefficient, that is the c over here, x to the power n. How do you find the derivative, right? So here, let me just change this to y. Okay, so here we have y is equal to x. Then we'll say that the derivative of y with respect to x will be dy over dx. We'll multiply this same power of, or the same coefficient here, c, by the power n. That will give us the cn over here. Okay, and then we have x to the power n minus 1. So simply multiply the coefficient by the power. C times n gives us cn. Then x to the power n, which we have here, minus 1. Multiply by the power, reduce the power by 1. Okay, so an example is that f of x is equal to 5x to the third. To find the differential of this, we will say f prime of x, then we'll differentiate. Multiply the coefficient of 5, right? So the coefficient is 5. We multiply it by the power 3, right? Then we would say 3 minus what? 1. We'll say 3 minus 1. So coefficient is 5 here. 5 multiplied by the power is 3. So 5 times 3. Then x raised to the power, the same power of 3 minus 1. You see, we multiplied by the power, then reduce the power by 1. 5 times 3 gives us 15. Then 3 minus 1 gives us 2. So the final answer is what? 15x to the second, or to the power 2. Okay. This is another example under the generalized power rule, or the generalized power function rule, where we have a function, say y is equal to 4x to the power negative 3 or minus 3. Then we would say the differential of this function is such that dy over dx is equal to, what do? We multiply this same coefficient of 4 by the power of negative 3. That will give us 4 times negative 3. Then the power is what? Negative 3 already. So it will be 4 times negative 3, x to the power, right? We'll say x to the power what? Negative 3 minus 1. Okay, so 4 coefficients by the power, x to the power, the same, negative 3 minus 1. Negative 3 times 4, or 4 by negative 3, gives us minus 12. That is minus 12x to the power negative 4. And that is negative 3 minus negative 1. That will give us what? Negative 4, right? Let's look at the other rules under differentiation. Okay, so we have the third rule, which is called the sum or difference rule, or 2 or more variables of the same function, right? So sum or difference rule. Sum or difference rule simply means that you are given the function, but the binary operations there will determine how you go about it. Okay, maybe you have a first term, right? Say f of x plus g of x, or it could be f of x minus g of x. It means that you have two different terms over here, but it is being separated by a binary operation, which is maybe a positive or a negative. So to find the differential of that, it is saying that dy over dx, right, or f prime of x, differentiate the first function given to you. So if the first term is what? F of x, or yes, f of x, we would say dy over dx is equal to f prime of x. You've differentiated the first term. If the binary operation being separated, that is, the binary operation separating the two terms is positive or plus, we would say f prime of x, which is the differential of the first term, plus g prime of x, which is also the differential of this second term, g of x. So if you differentiate f of x, you get f prime of x. If the binary operation is plus, you bring it there, and then you differentiate g of x, you have what? You have what? G prime of x. So let's look at this typical example, or a practical example under the sum or difference rule. We have an example which is saying find the derivative or find the differential of the function y equals 3x cubed plus 2x squared plus x. Well, we see that we have y over here, so definitely if you are differentiating, we would say dy over dx, right, which is already here. What we do is that we can see this is a function on its own, this 2x was also another function, and then this x is also another function. We have one term here, second term here, we have a third term here. So there are three terms over here being separated by a binary operation plus or addition, right? So we say dy over dx. Then we'll differentiate the first function. Multiply the coefficient of 3 by the power of 3, that will give us 9, right? Reduce the power of 3 by 1, that will give us 2. So the differential of 3x cubed is what? 9x squared. Then plus the differential of 2x squared. Multiply the coefficient of 2 by the power of 2, that will give us 4. Reduce the power of 2 by 1, that will give us 4x, 2 minus 1, which is the same as 4x to the power 1, which is also equal to 4x, right? Then the last term is what? X. If you differentiate x, you get 1. So the differential of x is 1, right? Okay. The differential of x is 1. Right. So it means that the differential of the function y is equal to 3x cubed plus 2x squared plus x is equal to 9x squared plus 4x plus 1. That is the differential of the function. Okay. Remember, under business mathematics, we are just learning these basic rules or basic principles, right? Under differentiation or under calculus, then we apply it in the business sense. So we could have these rules being the standpoints, then you apply it, right? So we have what is called the application of differentiation. We're going to apply what we learned here. Say we've been given an example like find the derivative of the total cost function, right? Which is giving us q cubed minus 4q squared plus 10q plus 75, right? We are being asked to find the derivative of the total cost function here. This is the total cost function. So what is it telling us? It's just telling us that we're going to differentiate the total cost function, right, which is C or TC with respect to quantity, right? I hope you can see that quantity Q here. So then how are you going to differentiate it? We'll say dC over dQ, the differential of the total cost with respect to quantity. Remember, if it is y here and then the variables over here are x, we'll say the differential of y with respect to x. So dy over dx. Here it is total cost and then we have quantity here. So it is differential of the total cost function with respect to quantity. So dc over dq. Then the same idea of differentiation. The general rule. Multiply by the power, reduce the power by 1. Would say 3. We'll multiply 1 here, that will give us 3. Reduce the power of 3 by 1, we will say we have 3q squared. 4 by 2 will give us 8. So 8q, reduce the power of 2 by 1, it will give us 8q to the power 1 is the same as 8q. If you differentiate 10q, or the differential of 10q is 10, right? So 10q, 1, right? 1 times 10 here. This, remember, this 10q is having a power of 1. So 1 here times the 10 will give us 10, right? And it will be 10q raised to the power 1 minus 1. 1 minus 1 will give us 0, right? So that is basically 10q raised to the power 0. And then any number raised to the power 0 is 1. So 10 times 1 will give us 10, right? Remember, we did what is called the constant rule. It says that the differential of any constant, any number without any variable attached to it is a constant. If we differentiate that, it is equal to 0. It goes away, right? So the differential of the total cost function, q cubed minus 4q squared plus 10q plus 75 is equal to 3q squared minus 8q plus 10. That's the derivative of the total cost function. Note, if you differentiate the total cost function, right, the differential of the total cost function. So if you differentiate total cost function, it will give you what is called the marginal cost. okay, the differential. So the D here means differential. So the differential of the total cost function, or the differential of any total cost function given, will give you what is called the marginal cost. So after differentiating this total cost function, we have this function here. This function here is the marginal cost function. So if you differentiate total cost, you get marginal cost. Okay. Okay, so let's look at the fourth rule, which is called the product rule. The product rule is used when you have two terms multiplying each other. We'll say given the function y is equal to f of x by g of x, then the derivative is expressed as dy over dx is equal to, so dy over dx is equal to f of x multiplying g of x, right? So f of x is multiplying g of x plus g of x multiplies your f prime of x, or yes. So I'm saying that the product rule, or say that the product rule is used, or at the time that we use the product rule, that means you have two terms multiplying each other. Say f of x is multiplying g of x. Okay, that's when we use the product rule. Product means times or multiplication. This is the formula for the product rule. It says pick the first term, right? Leave it as it is. Don't do anything to it. Multiply it by the differential of the second term. Plus, here you do the reverse of what you have here. So first term, keep it. Don't do anything to it. Multiply it by the differential of the second term. That is why it is g prime of x. Plus, remember it is product rule, multiplication. So the sign will change towards positive. Now, you keep the second term, right? You multiply it by the differential of the first thing, which is f prime of x. Okay, so basically this is the rule for product. This is the product rule formula, right? So if you have two terms multiplying each other and you are being asked to differentiate, or you have to differentiate that function, what you do is that you are going to use the product rule, and this is the formula, right? This is not a maths class, so I would urge you to just ignore this, right? Because this is just a proof of how we got this formula. This is just going to show you the step-by-step approach of arriving at this final formula over here. So what you need is the formula, okay?